All right, so fundamental counting principle first of all, and we're also going to talk about permutations. Now, if you guys remember combinations and permutations from last year, that was the hardest part about those was not necessarily the formulas. The hardest part is figuring out which one is which. I still don't like to do that, okay? I will tell you in this book that combinations and permutations are separated by like 30 lessons or something like that. So those of you who are not joining us next semester, not even going to have to worry about combinations. I don't think. I might be wrong, but I don't think you're going to have to worry about them. So every problem you're going to have is a permutation. Now, every problem, just like these two up on the board, that are both permutations, I wouldn't even use the formula for. All right, for this, we've got how many different ways can the numbers 2, 4, 9, 1, and 0 be arranged in any order if no repetition is permitted? Well, we've got 5 numbers there. I would make 5 blanks here. How many numbers can go on the first spot? 5. How many can go on the next spot if no repetition is permitted? 4.
3.
Yeah. What is this better known as? 5 factorial. We solve that. We get how much? Close. 120. 120 different ways that those numbers can be arranged. Okay. Now, this is what I would do. Technically, you could use the permutation formula to get it figured out. All right, but I would do it this way instead. All right, if we go down to the bottom one, how many 4-letter signs can be made from the letters in the name Ashley? All right, so once again, we've got 4 spots here. How many letters can go into the first one? 6, because there's 6 letters in her name. Now, are any of these letters the same? That is something we should have looked at first, because that is important. All right, they're all different, so it doesn't matter here. So this would be a 6. Once we have that one, this would be a 5, a 4, and a 3. And this ends up being 360 different signs. All right, like I said, that's how I would attack these problems. Okay, those of you interested in stats, we do stuff like this in stats. All right. Any questions there at all? All right, next page. Paul, thanks for taking such good notes there. Appreciate that. Setting a good example for Chase to get his work done. And since we only have so many tests left, I'm guessing one of those tests, you guys would like one that's like up here on the board, huh? You got a multiple choice final? With only 12 questions on it? Oh, that is true. We'll talk about that. Hopefully we have school during finals.
We don't have school. Is there no finals?
It's up in the air. I might, because this is college class, I might not have a choice. We might have to have a final.
Finals because the people that are on that would be online.
We'll figure out a way to get it done.
I don't think we're having finals. That's what I'm.
Who's online?
Marion.
They could be here. They're just not here.
Yeah, but our entire class could get Rona like next week.
Oh, is that how that works, Ethan?
Sometimes.
Really? I didn't know that.
Because we share water bottles.
What?
I'm gonna eat a bat.
That'd be something you would do. But you gotta get the right kind though, right? I've got some extra ones in my garage if you want. I've got some extra ones in the garage if you want. I'm sure you've got some extra ones. All right, so what we have up there, we have a multiple choice test. Has 12 different questions on there. And for each question, you have 5 possible choices. How many different ways could you provide the answers to that test? So it's kind of the same thing. We could, and I'm not going to list them all out here because you're going to see the pattern in a second. But you could list out 12 different things here. All right. For problem number 1, how many different options do you have there? You have 5. For problem 2. And then you would multiply these, right? And you would keep going until you get 5 to the what power? 5 to the 12th. So, any idea what 5 to the 12th is? Oh, not that number.
5,000, 500,000.
500,000. How about?
4 million.
Try again.
244 million.
There you go.
140,000.
Yep, there you go. How many different sets? So it'd be over 244 million different ways to answer that test. You sure you want a multiple choice test?
Yeah.
Well, first of all, I won't give you 5 choices. I'll give you 4 probably. So that'll narrow it down a little bit, but I'm not only going to give you 12 questions. I'd give you, I don't know, 200. Okay. That's going to take a long time for me to make, but if that's what you want, I can get it done. You sure you want that? You sure you want that? Here, Caleb, just for you. This is your question for your final. If you want one question, pass or fail.
Oh, I got that. It's 6.
Actually, here. It is the limit.
Limit of x is 0, so x has to be less than 0.
No solution.
You sure?
Don't have -1.
Caleb? Your grade only depends on it. No big deal.
He's already got it.
You're infinite. What's the answer? No solution.
The answer for that one was 0. I even gave you an easy one. I asked that one day too. I was coaching 3rd grade baseball, and they're like, oh, give me a really hard math question. So I gave them that one, and they just threw out a question. I'm like, huh, my seniors don't even know that sometimes. So
Was that with us?
no, that was younger than you guys. No. All right, bottom question down there. All right, go ahead and do it. Go ahead and do it. How many 4-letter signs can be made from the letters in the word numeral if no repetition is permitted? Jacob's got it down on his paper already, I assume, don't you? You should probably get that done. Maybe your final should just be how well your notes are.
I have this many notes.
I have
Yeah?
that many notes.
That's a lot.
And that is way better than last year. Way
Last
better.
year I had like half a page.
Yeah, I know. I was your teacher for part of that. I wasn't your teacher for long, but I was there. All right, what's going into the first spot, people? 7, and then what's the answer? 840 different signs. Make sure you label these. Okay? Any questions? All right, off we go. Now we need to write a quadratic equation with a lead coefficient of 1, whose roots are -3/5 and 1/2. All right, believe it or not, you guys did this last year.
No.
Maybe not with these answers, but you have done it before. Mr. Quislen even taught it to you guys. Or did you guys have Mr. Bartram? I don't know how long he's been here. No? Okay, you guys all had Mr. Quislen. Okay, the first time around, Colin, just so I don't get you confused. Mr. Quislen taught it to you the first time around.
Yeah, probably I never had Bartram.
No, I'm just saying. He didn't teach it to you in geometry. At least I don't think so. All right, so what are roots here? What do those stand for? Thanks, Chase. Appreciate it. Do we know what that means, though? Kenzie, what is it? Okay. Right, when the equation equals 0, these would then end up being where it crosses the x-axis. So maybe we have a parabola that looks like this. These two are the roots. Okay. Well, this time what we're given is we're given the two roots. We need to come up with an equation for that. Okay. So how we do that, first of all, is we set each one of these answers are what x equals. All right, from our answers. Then what we want to do is we want to find the factors that would give us that answer. So we're going to set this equation equals 0. So we're going to add the 3/5 over. So we've got x plus 3/5 equals 0. And then we'd subtract the half over. So x minus a half would also equal 0. Once we get there, then we have two factors here. We have this one and this one. What do you think you do with the factors? We FOIL them together. Yep. So x times x is x squared. And then we've got minus a half x plus 3/5 x. And then minus 3/10. All right, we're getting close to being done. What do we have to do with that? We don't have to change all of them to tens, but we do have to combine our like terms here in the middle. So this would be the same. This middle one would be the same as negative 5/10. And then this one would be a positive 6/10. So in the middle then, we would have a positive 1/10 x minus 3/10. All right. Does that answer the question?
Yes.
Maddie, you're saying no. Why not? Okay. Do I have a quadratic? Is that a quadratic? Yeah. It's an x squared, so it's quadratic. Is it an equation, though? No. Right now, it's an expression. And an equation, what do you want to do?
X squared equals negative
0.
Okay, you could set it equal to 0, or you could set it equal to y. If you put an f of x here, that becomes a function, so we want to stay away from that. So either one of these two would work. Either y equals the rest of it, or all of this equals 0. Both of those would work. All right? Just one. Huh? This is the answer, yes. Okay. Now, the one thing to realize is leading coefficient of 1, that's our number out in front of our x squared, right? Okay. Sometimes they might ask, say, what's the leading coefficient, or what's the equation with a leading coefficient of 4? What would you have to do for this whole thing then? Yeah, just multiply everything by 4 here, and then you'd get that answer. All right. All right, now down below, we've got a little bit more complicated roots, okay? But you do the exact same thing. So x equals 1 plus square root of 2, and x equals 1 minus the square root of 2. From there, you get them set equals 0, so we've got to move these to the other side. So we've got x minus 1 minus square root of 2. And for our second one, we'd have x minus 1 plus the square root of 2. From there, what do you think we got to do with those? We got to multiply them. Okay, now a big thing with this one, because it's a much bigger foiling problem here, all right, it's very important to stay organized. What I like to do is, first of all, I'll take the first term in the first one and multiply it by everything in the second one. So x times x gives us an x squared. X times negative 1 is a negative x. X times square root of 2 would be a positive x squared to 2. Then we're going to take negative 1 times all three of these. All right, and instead of putting it behind it, I like to line up my like terms. So I'd say -1 times x is a negative x. I'm going to put it below the other x term. -1 times -1 is a positive 1. We don't have one of those terms, so I'm going to throw it on the end. And then -1 times square root of 2 is a negative square root of 2. Okay, from here, we take negative square root of 2 times all three of these. Negative square root of 2 times x is a negative x square root of 2. Notice the square roots are going to cancel out here. That should happen just about every time. All right, negative square root of x times -1 is a positive square root of 2. There's going to go that one. Negative square root of 2 times positive square root of 2 would be a negative square root of 4, which is the same as -2. And then we just add up our like terms here. X squared minus 2x, this goes away, -1, and that goes away there. Okay, and then equals 0. Yep. All right, so there's our equation. All right, any questions at all there? All right, moving on. Okay, these two write down. I'm going to do it differently than the way they do it in the book. Okay, I have been told by lots of kids that this way is a little bit easier than the way they do it in the book. All right, but if you don't like it, that's fine. You can do it the other way. All right, so just copy down the top one right now, and then I'll give you time to copy down the bottom one afterwards. All right, so as you can see, Jim and Alice are driving for 225 miles at 75 miles an hour on their first leg. So maybe they're on the interstate for that part. Then they got to go onto a highway. They figure they have to drive 120 miles and they're going to average 60 miles an hour. What is their overall average rate for the whole trip? All right, now with all of that going on there, what I've come up with is I've noticed that if we do another chart for this, once you fill in the entire chart, you are going to have your answer there somewhere, okay? So we're going to use distance, rate, and time because that's what we're talking about in this problem. All right, we've got a first leg here of 225 miles, so that's our distance. And we have a rate of 75 miles an hour. So then for that, can we figure out the time? What is it? 225 divided by 75, better known as 3. Okay, but that's how you figure it out. 225 divided by 75 will give us our time for that. Then we go to our second leg. All right, we see that it's 120 miles there with a rate of 60. What's the time for that one? 2 hours. All right, so what we want to find out here is we want to find their overall average rate. So what some people are going to try and do is they're going to say, all right, 75 and 60, those are my rates. I'm just going to average them together. And that would be wrong. Okay, and the reason is because we are not driving them for the same amount of time. If the time was the same, you could do that. But because they're different, we have to have a different game plan for this. So we need another column here. All right, and we need to look at the total for it. Well, we can figure out what the total time is. How much is the total time? We just add those together, right? We can figure out the total distance. by adding those. And now, can we figure out what the total rate is? We would just take 345 divided by 5, and we end up with 69 miles an hour. All right. Now, as you can see, once we got that last piece filled in there, our chart is completely filled in. Your answer is going to be part of the chart. You just got to completely fill in the chart. Okay, so one down below, go ahead and copy it down. How fast must they drive for the last 145 miles to have an overall average rate of 70 miles an hour for the entire trip? While you're writing that down, I'm going to recopy part of our chart up above because we need it. All right, so from there, we just need to fill in the stuff that we know. Things that we know the last leg is going to be 145 miles. So we're going to put that in for our distance. Another thing that we know is we want our total overall average rate to be 70 miles an hour. We can put that in for the total rate here. All right, and then we can figure out some other stuff. Do we know what the total distance is? How do we do it? Yeah, we just add these together. So 345 plus 145 is 490. What else can we figure out then after we found that? We can find the total time. What is that? 7, because it's 490 divided by 70 gives us 7. If we know the total time is 7, what can we figure out next? Yep, our t has to be a 2 here. And then can we figure out the rate? Yeah, 145 divided by 2 would be 72.5 miles per hour. All right, so another one where if you completely fill in that chart, the answer is just there. Okay, so any questions there? All right, make sure you practice those in your homework. Okay, they are a little bit new. All right. Yeah, we got another one to do. All right, let's go. Lesson 39, radian measure of angles, and we're going to talk about forms of linear equations. If you guys want, I'm going to teach it to you the long way instead of the short way. Actually, while you're doing that, as long as you don't want, I'm going to get rid of a page. And I'll shorten stuff up later. All right, so this is something that you guys have already done a lot of this year. Okay, we need to figure out what 4 sine of pi over 4 is, plus sine of negative pi over 3. All right, now the new part for this year is this thing. That's in radian form right now. Okay, it'd be a lot easier if we could get into degrees. How do we change from radians to degrees? Do you remember? Do it on your calculator. What are we going to multiply by? 180 over pi. Very good. So And what happens here is these pi's should cancel. 180 divided by 4 ends up being 45. So 4 sine of pi over 4 turns into 4 sine of 45. And then we're going to do the same thing for the second one. We're going to multiply that by 180 over pi. Pi's cancel. 80 divided by 3 is 60. So we've got sine of negative 60 degrees. All right, from there, what do we have to do? We have to graph them. All right, so sine of 45 degrees, we're in the first quadrant. Reference angle of 45 means we've got 1 square root of 2. All right, signs are all positive for that because it's in quadrant 1. So we take sine of the angle, which would be opposite over hypotenuse. So we've got 4 times 1 over the square root of 2. Okay, if you wanted to simplify that quick, this would be times square root of 2 over square root of 2, which would be 4 square roots of 2 over 2. I'm going to leave that like that for now. I understand that you can simplify these, but we're going to leave it. All right, sine of negative 60. Negative 60 degrees is going to be in what quadrant? 4. We're going to go down 60 degrees here. So we're down here. 60 degrees. So we've got 30, 60, 90 triangle. 1 square root of 3 and 2. Are those right? No, we've got to have a negative here. All right, so sine of that would be negative square root of 2. Sorry, negative square root of 3 over 2. And then we've got common denominators here, so we can just put them together. 4 square root of 2 minus square root of 3 over 2. Now, for some of you, you like to use your calculator for the whole thing. All right, the next test, which I haven't decided when that's going to be, but the next test will be half calculator, half no calculator. So if you're just throwing this whole thing into your calculator and it spits out this answer, it is probably time to figure out how to do these. Okay? So, any questions on what you see up there? All right, next one. A lot of the same stuff. Sine of 13 pi over 4 plus 3 cosine of negative 5 pi over 3. First step is to do what? We're going to multiply by 180 over pi. Pi's cancel. 4 and the 180 turn into 45. 13 times 45 is 585. For the second one, we do the same thing. Multiply by 180 over pi. Pi's cancel again. 180 divided by 3 is 60. Times negative 5 would be negative 300. All right, now what we've done before with this one, we've done these. All right, we should probably subtract 360 out of there to get this down to 225. And then we've got to graph those. So 225 gets us down into the third quadrant. Reference angle of 45. So we've got 1 square root of 2. And then both of these sides are going to be negative because we're going to the left and we're going down. So then sine of this becomes negative square root of 2 over 2. For the other one, cosine of negative 300, where does that go? Yeah, it comes up to quadrant 1 here. All right, so we start at 0, we go down, negative 90, negative 180, negative 270, negative 360, so it's got to be within those two. This would be 60 degrees, so we've got square root of 3, 1, and 2. So cosine would be 1/2 here. So we've got 3 times 1/2. Once again, we've got common denominators here. So you can either write it as 3 minus square root of 2 over 2, or I just put it so that the 3 is out front. You could also go negative square root of 2 plus 3 over 2. Both of those are the same. All right, any questions at all there? The only thing that's different that you guys haven't done yet this year is we changed it from radians to degrees. Once we've gotten it to this point, you guys have done this many times so far this year. All right, any questions at all there? All right, this one you got to write down. This is the last long one of the day. And then it'll be nice and quick for the rest of it. All right, so for this one, we are trying to figure out how far it is from LA to the equator if the diameter of the Earth is 7920. So I've got a little picture here. All right, and we'll say that LA is maybe about there. All right, now latitude, what that measures is that just tells us how many degrees above or below the equator that would be. All right, so what they're saying here is the arc measurement between the equator and LA is 34.05 degrees. All right, now if we wanted to, if we just looked at this two-dimensionally and we drew a line right into the center of the Earth, this angle that would work with the equator would also be 34.05 degrees. Okay, now what happens for this is we need to find not the arc measurement, we need to find the arc length. All right, because as we know, the Earth is curved, it's a sphere, so we need to find the actual distance that you would travel to get to the equator. All right, now for whatever reason, you guys know that for a lot of our variables that we use, there's a reason for it. Like we use D for diameter, we use R for radius. All right, for whatever reason, arc length. Anybody know what it is? Arc length is S, and a perfectly logical reason for it, which I have no idea what it is. All right, but anyway, so arc length is S. And to find this arc length, the simplest equation, there are two different ways to do it, but the simplest equation is S equals R times theta. All right, and theta is always in radians. Okay, so if you want to use this equation, you're totally fine in doing it, but you have to make sure that your angle measurement is in radians. So this 34.05, we need to change to radians first of all. How do we do that? What's that? Pi over 180. That's correct. We're going to multiply by pi over 180. And then whatever that answer is, we're going to take times the radius. What's the radius? Okay, we would just take our diameter and divide by 2, right? Okay, so whatever this ends up being, and I don't remember. Yes, that's correct. 2353.37. Now, we should have a label on here, shouldn't we? Do we have a label in the problem? No. So we're going to have to say units here. All right. I have no idea. It doesn't make a whole lot of sense that this would be miles, but it could be. Could be kilometers. It could be meters. I don't know. There's no way to know. All right. So that would be our answer for that. All right. So if you're going to use this equation, totally fine. You just got to make sure you change your angle measurement to radians. All right. That's the big part of this one. All right. Next page. Do not write it down, and I'll explain why as we go here. Okay. What you see up there on the board is you see 6 different ways to write a linear equation. Okay. The one that you guys are most familiar with is this one right here. Slope-intercept form. You guys have been using that one for a long time. All right. Technically, all 6 of these would be equivalent. Okay. The other one that we use a lot is point slope form. All right. Now, what they're going to ask you, yes, Ethan.
How is standard form and general form the same? Because you subtract the C over this plus.
It's just a generic way to write it. C can either be positive or negative here. You're right, though. Okay. It should look like this should be a minus. Okay. But C can be any number, whether it's positive or negative. Okay. Now, for this, for all of these, you can write them in any form you want. Okay. I don't want you to waste your time. Okay. I don't care what the directions say. You can pick any one of these you want to do and do it that way. What I would highly recommend is I would highly recommend this one. Okay. But if you want to do slope-intercept form because you're most comfortable with that, that's fine too. All right. And the reason why I say point slope form, and we do this a lot in calc, is there's much less math to screw up on in point slope form. Okay. It's not as simplified as you could get, but you don't have those extra screw ups that happen along the way. Okay. So what I mean by all of that is for these next 3 questions that I'm going to show you are all questions right out of the homework. This one right here, right, y equals -7/3 x plus 1/2. In general form, do I care about general form? No, don't spend the time on it. If this question gets asked to you in your homework, write down the equation of the line. Can we handle this? Okay, I know it's tough, but I think you can handle it. All right, now, the one that I would be more interested in you guys knowing how to do is this one down below. Okay, really what this question is asking here is find the equation of the line whose slope is -1/3 and it goes through this point here. All right, well, if you have that information, this is set up perfectly to go into point slope form. So we would go y minus 5 equals our slope times x plus 2. If you're going to do point slope form, this absolutely has to be in parentheses here. Okay, if it's not, it's wrong. Okay, but that's as far as you have to go. You don't have to transform it into anything. On a test, on a quiz, I will always ask you to just write the equation of the line. I don't care which way you write it. Okay, is that fair? Okay, in the homework, you're just going to have to remember that. Just give me the equation of the line. All right, so super tricky question. Maddie, you ready? You're going to do this one. Yeah, you're going to do this one. Give me the equation of that line. I'll help you out. It starts with 2x. Say that again. There you go. That's all I got to do. And there's your answer. Okay. You do not have to worry about putting it into those other formats. It's a waste of time. Okay. The first year I taught this, I made them do this because I didn't know any better. Because I couldn't remember calc at that point. I didn't know what they did in calc. Now I kind of sort of know. So you'll never be asked what double intercept form is. And to be honest, until I taught this class, I had, if you go back to this list here, I still haven't really heard of this one. Oops, the bottom one down there before. Okay, double intercept form. I've seen it before, but I've never used it before. So if I've never used it in engineering or teaching math, I don't think we need to know those. Okay, so. All right, homework is, what do we do today? 38 and 39? 38 and 39, 25 questions. Good question, Taryn. This is going to be due Monday, November 30th. No matter how mean you think I am, I'm not going to give you a quiz the day after a 5-day weekend. So, just got to get the homework done. I'm not going to give you a quiz on it. Okay, Caleb wants a quiz. Yes, you can. Caleb wants a quiz. We'll give a quiz. Just like Max during third hour was asking for, yeah. What was Max asking for? 30 questions from each lesson. So they got 30 questions. All right. And apparently I was so excited that they already left. So.